Well, good afternoon, everyone. It's my pleasure to introduce Del Smith from Normandale Community College on vacuum and thin film technology. I asked Del about 2 months ago because I read a story in the Star Tribune in April of this past year about what he's doing at Normandale. So I invited him, and he said he would be pleased to come here. He just got out of class, he said, at 10 to 12. So he made it. Just a couple highlights from this Star Tribune story. The headline is, Normandale offers cutting-edge degrees in thin film. Computer firms are begging for program graduates. Oh, what is this? And if you're like me, I didn't know much about this. It's been around for a few years. And so, as I said, I invited Del, and he was happy to come. Normandale in Bloomington is the only community college in the United States that offers an associate degree in vacuum and thin film technology. Did not know that. This is a quote from Del. There are probably 300 vacuum technicians working in Bloomington right now, and there are companies in New York State that are begging for our graduates. The college is in the second year of a 3-year, $800,000 grant from the National Science Foundation that supports the telepresence instruction. That was the highlights of that story. Del is a graduate of the University of Minnesota. He's worked in high-tech companies in the Twin Cities his entire career. Over 30 years was spent at Honeywell Aerospace, where he was the lead engineer in 2 different areas, the thin film facility and the vacuum laboratory. He was a member of the team that established the vacuum and thin film program at Normandale in the mid-90s and taught part-time for a few years. The program was started at the request of several local companies who recognized the need for more educated technicians in the equipment they were using as the equipment they were using became more complex. Del returned a few years ago to teach part-time. 3 years ago, he retired from Honeywell and has been more involved in Normandale since then. So please welcome Del Smith from Normandale.
As John said, I've been with Normandale for a long time. I've been working in the field of vacuum and thin film technology for over 40 years. So obviously I still enjoy it. It's an interesting field, and I'll see if I can't get you a little bit of information about what it is that we're talking about. We're not talking about vacuum cleaners. Although I've heard all the jokes that I think could possibly people could come up with. So go ahead. It's not vacuum cleaners. It's not HVAC, which is heating, ventilation, and air conditioning, which it's often mistaken for. It is not low tech. It is very, very high tech. It's pushing the state of the art in several different fields. It's also not familiar or visible to most people. Is there anybody in here who would say they're familiar with vacuum and thin film technology? One, yes, Dr. Esther. She's been by the class a couple of times, so that's pretty typical. Very few people know what we're about. So go ahead. Okay, so why vacuum technology? What are the things that you can do with vacuum technology? Well, just about anything you can think of has been touched in one way or another with vacuum technology. A lot of things in our life would not be possible without vacuum and thin film technology. Computer chips, any electronics. If you have any electronic components, any electronic devices, you owe a debt of gratitude to vacuum technology. Aerospace navigation systems. It turns out that right here in Minneapolis, Honeywell is the world leader in navigation systems, and they are laser-based, and they are a vacuum. They're actually a vacuum device that almost every commercial aircraft you fly on is going to be guided by a laser navigation system. So there's lots of vacuum that goes into that. Decorative and wear coatings. A lot of the higher end plumbing fixtures and so on, faucets and so on, they're often coated in vacuum technology, in vacuum systems. Wear coatings. If you go to Home Depot and buy a set of drill bits, you're going to see some that are titanium coated. That's done in vacuum, and the Twin Cities is a pretty significant player in that wear coating industry. A lot of that technology was developed here. Energy efficient windows. If you have a low-E window in your house, you can thank vacuum technology for that. And it turns out Minnesota is really a major player in energy efficient and decorative windows. As a matter of fact, there's a company in Owatonna that has provided about 85% of the glass in Las Vegas on the Strip. So all of that, those attractive buildings with the different colored glass, and some of it is energy efficient and so on, a lot of that comes from Minnesota. And it comes from vacuum systems that are very large. Physics research. Minnesota was really a leader in developing some of the capability to look at surfaces very, very minutely. Dr. Paul Palmberg at the University of Minnesota founded Physical Electronics, which is a world leader in that kind of equipment. And they're located just a few miles from here. And that's their primary issue, is surface analysis or failure analysis. LEDs, the new lights that everybody is getting, they're absolutely dependent on vacuum technology. Flat panel screens, your TVs, anything that you're seeing in the flat panels. Then there's a couple of other areas that aren't quite as, well, they aren't quite as high tech, but they're still very important. Purifying metals, vacuum metallurgy, it's a very, very large industry, not here in the Twin Cities. And then packaging food. Hormel in Austin actually is a fairly large consumer of vacuum pumps for vacuum packing things. And you can go down to Target and buy a vacuum packer, and by the way, they work. So, go ahead. And can somebody give me like a 10-minute when I've got 10 minutes left? Sure. Okay, so just a quick look at things. Cars, most cars now have anywhere from 40 to 50 computers, maybe more. And remember, the founder of IBM at one point said that he thought that there was a market for about 5 computers in the world. Now your car is going to have 10 times that many. Up in the upper right-hand corner that's actually a picture of a ring laser gyroscope built here in Minnesota that will guide you on your next flight wherever you're heading to. On the bottom in the middle is the Large Hadron Collider, where the Higgs boson was developed. That's the largest vacuum system in the world, about 17 miles in circumference. It's a large stainless steel system that's just unbelievably huge. Someday I'd like to get there and visit that and see it, but I doubt that it'll ever happen. Okay. So we've talked about what vacuum isn't and what it's used for, but what is vacuum? Well, the ideal definition is a space devoid of matter. It's impossible to achieve. Even in interstellar space, the vacuum isn't that good. Okay, but there's not much in a good vacuum. There's not much. Another definition is a space at less than atmospheric pressure. Atmospheric pressure, the air pushing down on us, it's about 14.7 pounds per square inch. Anything less than that is considered vacuum. Now, the third definition is really the one that counts. A space which has had the gas molecules removed to the extent reasonably practical by artificial means. Can we pump some of the gas molecules out? And then why would we want to do that? Because everything changes when you've got fewer gas molecules present in a system. You can do things that you can't possibly do any other way. And you can see vacuum can be created with a pressure of whatever that number is. It's a very, very, very small number. pounds per square inch. We don't work in pounds per square inch. We use other units of measure that are a lot easier to work with. Go ahead. So we've talked about vacuum, but our program is also, it's vacuum and thin film technology. So what's thin films? Well, thin films are very, very thin films of various materials, and most thin films have to be produced in a vacuum system, in a system that's under vacuum. The example of thin films that we see is soap bubbles. You can see the colors on those soap bubbles. That's the interference fringes from the thin soap film. Actually, that's a fairly thick film that you see in those bubbles, but it's right on the edge of qualifying as a thin film. We're talking about really, really thin coatings here. If you were to put a coating together that's 30 atoms thick, it would be about 100 angstroms thick. Angstrom is a unit of measurement of a very, very small distance. So 30 atoms will comprise about 100 angstroms thickness. And 100 angstroms, you can see, is, again, a very, very small number. So another way to look at that is that 30 atoms thick is, well, I did not update this slide. A hair is about 4/1000th of an inch thick. So a typical hair is going to be 30,000 atoms thick. Okay, 30,000 atoms, just the diameter of and that's a fairly small hair. That might be a blonde hair. They're fairly small. Yeah, and as we get older, our hair gets thicker and bigger. Well, not necessarily thicker, but thicker in diameter, what little there may be. You can measure so in other words, we do about 30,000 atoms in a thin film, or we're less than 30,000 atoms thick. There are capabilities within the city of Bloomington to create films that are only maybe 4 or 5 atoms thick. That's tough to even measure. But we can measure it with optical techniques or mechanically. We have a profilometer at Normandale that can measure about 500 or 600 angstroms thickness. We can't get down to just a few layers. That would be very, very expensive. Just our profilometer costs about $35,000 that can measure several hundred. Okay. So what does a vacuum system look like? We've talked about vacuum systems. Well, in the upper right-hand corner, we have a picture of a vacuum system that's used for research. And you can see by comparing it to the computer screen or the toolbox, it's about the size of a table here. And not particularly large, but has a lot of stuff on it, almost exclusively made out of stainless steel. Most materials are not very compatible with vacuum, so we need to use stainless steel, and we even have to be careful about what particular version of stainless steel we use. On the right-hand side is a picture of an optical coating machine, vacuum system. To give you an idea, that cube, it's about 3 feet in each dimension, and about 3 feet deep. So, and that would be used for coating eyeglasses, your anti-reflective coatings, your protective coatings, the anti-scratch coatings, and so on. Those are all done in vacuum. And in fact, we have fairly large manufacturers here in the cities that do some of that work. Okay, so that's, and the smallest vacuum system that we can work with, we have one at Normandale for preparing samples for biological samples, it'll sit on a table. It's pretty small. You could carry it around. The other extreme is in the lower left-hand corner, and that is an architectural glass coating machine. It's about 150 feet long. Some are larger than that, and there are several systems like that in Minnesota. So it's a big industry, especially around the Owatonna and Northfield area. Cost per system, $500,000 to tens of millions of dollars. An inexpensive vacuum system for production work would be $500,000. You'd be hard pressed really to find something for $500,000 that would do much. Tens of millions on the other hand. Now, this next statement I think is really interesting. There are 3 semiconductor or related fabrication facilities in Bloomington. And each one of them, if you were to value the equipment set that they have in each one of those fabs, each one has about $1 billion, with a B, dollars worth of equipment sitting there producing the semiconductors. And those are, that's a lot of money, but the big facilities are a lot more expensive than that. So now you can imagine, go ahead, you can imagine with that, that's why the companies are concerned about the people that work on these systems, and especially repair and maintain them. You do something wrong and you can shut down a $25 million system, and that's painful to the bottom line. So as was mentioned by John, the program at Normandale was started in the mid-90s. It was Seagate, Polar Semiconductor, back then they were VTC, Cypress Semiconductor, and Honeywell that were really pushing for, we need trained technicians, we need to have the proper education so that they can do a good job of maintaining this equipment. They can't afford downtime. It's a very, very competitive business. And so any downtime at all is a real problem. So as he also mentioned, we're the only college in the United States offering an Associate of Applied Science in this particular specialty. There are other schools that teach some of this technology, but they're usually in conjunction with a vacuum or with a semiconductor manufacturing degree, so they don't go into as much depth as we do in the vacuum technology itself. And that's one of the reasons why we've gone to, and I'll talk about it in a minute, the National Science Foundation grant. Most of these places need this education, but they don't have the capability to provide it. So what do we study? Well, in addition to all the requirements, the state requirements and so on for what constitutes a degree, the general education requirements. We cover vacuum science. We have 3 core courses there. Robotics. There are robots typically in these vacuum systems that are moving things around. People are too dirty, so we want robots. Electronics and automation, you can imagine they're highly automated. Fluid mechanics, a lot of valves, a lot of things going on in these systems. Math through college algebra. We do not require calculus for the technician program. And that's one thing that is I think, not well understood, that people can get into these high-tech industries without calculus. Calculus washes a fair number of people out of college who try it. And a lot of times people are not, when they first get to college, they're really not quite ready to take on something like that. So we do not require calculus. We require entry-level college physics and entry-level college chemistry. So go ahead. So what have we done? So who cares now that we've got all this good stuff? We've trained several hundred vacuum technicians. The vast majority have stayed right here in the southern metro area. There are a lot of companies that use them in addition to the ones I mentioned. Just for general information, we also work with the customized training department to provide training that's really focused on specific industry needs. We've worked with a couple of companies in Bloomington on that. And so sometimes people need to know just a very specific part of the technology for what they do, and we have the capability to do that, although we're so busy that it's tough to keep up with the demand. Go ahead. Okay, so National Science Foundation grant. What is that all about? Well, we applied a few years ago, and in 2014 we were funded $793,000. It's a 3-year project. We're just finishing up the 2nd year. What have we done with it? Well, we've updated the curriculum. We designed and built 4 high vacuum equipment trainer systems. I've got a picture of them here. And we installed telepresence capability in the vacuum technology classroom. Now, telepresence is what I call video conferencing on steroids. We have large screens in our classroom, and we can see the students at a distance. And you might say, well, what kind of a distance? Well, we've had students from Northern Ireland that have sat in on have attended and gotten credit for our class. And it's real time, it's through the internet, it's high speed, so it's very high definition. I can actually see the expressions on my students' faces, even if they're several thousand miles away, and I can therefore find out if they're following me or not. And that's really critical. You can't just talk. You have to teach. You have to interact with the students, and especially for this technology, which is tough for people to understand at first until they get a handle on it. We have updated the curriculum to accommodate working with students at a distance. We're now working with Stout State in Wisconsin. In fact, I just finished the class with half of my students were at Stout, half of my students were in my classroom in Bloomington. And that was a class I finished at noon. We have demonstrations. We have these vacuum equipment trainer systems, are systems that we can ship out to the remote locations. And so the students not only are watching, but they can do hands-on work with the systems. They can do their lab work, they can do experiments, they can run the system and get a really good handle on that. We have a very significant involvement of our industry advisory group, which we're meeting this Friday afternoon. And we've got people from several different of the major corporations. The University of Minnesota is represented. And we recruited technicians from each of those to help us design the system so that we would cover everything that they thought was needed. Typically, the students or the technicians that we recruited are responsible for training new hires in those companies, so they knew exactly what they needed. And so we were able to hit about 95% of the things that they wanted to do in the trainer system. So go ahead. This is a picture of our Telepresence Classroom. I need to get a new picture of that because this only shows part of it. We actually have 3 large screens like that. This is actually a picture in our classroom, and those are the students that were in Northern Ireland. So you can see how well we could see them. The audio is just as good as the video. We can actually work back and forth. The students can talk back and forth and share things. We have joint projects during the class where the students, no matter where they're located, are all working together to solve problems or design a system or things like that. So that's one of 3 screens. The second screen shows the content, whatever it is that we're talking about. Might be PowerPoint presentation, it might be a video. The third screen, I can actually select whatever I want on that one. And there are cameras, and one of the nice things about telepresence is that the cameras automatically follow whoever is talking. So I don't have to, as the instructor, spend a lot of my time running the system. If one of my students is asking a question, the camera will swing over to that student. And not only that, but it will zoom in. So typically they're seeing one person. So it's a very sophisticated technology. We were fortunate to be able to buy it from the state of Minnesota has a grant for educational institutions for equipment. So if we get either monetary donations or donations in kind, and the companies around here are really wonderful at donating their older equipment that's still functional, whatever value that is, the state will match for us to buy other equipment. And it's a great program. It allowed us to do this. So the next one, this is a picture of the vacuum trainer that was designed locally, and our students actually helped build it. We've got 4 of these, and the students can operate them. This is a relatively low-cost system. As it sits, it's about $20,000 worth of equipment, not including the labor that it took to put it together. So it's really bare bones budget, but Dr. Esther appreciates that. We try to keep the cost down, but there is no such thing as a cheap system in vacuum. So, questions, comments? Yeah.
University of Minnesota has something like this?
Yes, they do not teach vacuum technology as such. But they do have a very, very good program in semiconductor technology, and we actually send some of our students there to take some of those courses. We work closely with the U, and so yes, they have a program. They really don't have courses like we have. And in fact, some of their grad students have said, you know, what we really need to do is get their grad students to take our classes so that they don't break all the equipment at the U. I have a friend who is one of the vacuum technicians at the university in one of their facilities, and he said that's the biggest problem is the grad students don't have the grounding in basic science and the technology of vacuum systems, and he's fixing them all the time because of that. Yeah.
Can you tell us about the demographics of your graduates and the incomes?
Good question. Demographics, a little bit of everything. Anywhere from sometimes we have high school students in the post-secondary program, all the way up to second career people who maybe are in their 50s. Most of our students are probably in their 20s. Some of our best students have come out of the military. And so it's a wide range. A lot of our students are currently working in the industry, but at an operator level, not a technician level. Operator level meaning they're running the machines, but they don't really know what they're doing. They're just following a recipe. Their income is on the order of $20,000, $25,000 a year. Our technicians, on the other hand, start at $50,000 to $55,000 a year, and those with a fair amount of experience can actually, with a little bit of overtime and so on, they're making over $100,000. Now, I'm not saying most of them are, but some of them are making six-figure incomes.
Could you elaborate a little bit more about the demand? You said there was
Yeah, good. Another good question. In our area, we have, like I said, like I think John mentioned, that about 300 technicians in Bloomington. A lot of them are approaching retirement age. A lot of them were trained back in the early mid 90s by us, and they were already working in the industry typically. So the demand, typically we see in the Twin Cities area 25, 30 openings a year, something like that. It probably is going to grow a little bit over the next few years. One of the issues is that this is such a unique specialty that it's not like there's thousands of openings like for an electronics technician. So that's one of the problems, and that's why very few places, in fact really only us, have a program like this. In order to make it economically feasible, we need students from all over. And if we can group, maybe 5 or 10 from one particular location, another 5 or 10 from another location, maybe 10 or 15 from here, it actually becomes cost effective to offer the program. Very few places have a concentration of need that is enough to support a full program. The problem, however, is that they need some people trained in this, and it's tough to get that training. Just to give you an idea, at Honeywell, which is the maker of the navigation systems, there are, between the vacuum lab and the thin film area that's doing mirrors for these lasers, they employ somewhere around 30 people. specifically in vacuum technology at this level, technicians and engineers. They're leveraging several $1 billion worth of Honeywell revenue. So it's not the number of students, it's the impact of the students that's an issue. Right now in New York, there's a fab facility that is planning on, well, they're growing, and they figured that for a while they will need up to 200 new technicians a year, but they're growing dramatically rapidly. That's really not a normal kind of a situation. But in the country, probably we're looking at a demand for 200 or 300 graduates a year, maybe up to 500. So spread all over the country, that's not very many at any given location, thus telepresence. Yeah.
Your telepresence classes, are these generally at company sites or academic sites? And what sort of guidance do the students have when they're off screen?
Good point. They both industry and educational institutions. We have partnered with both, and we plan to continue to do so. Industry is very interested in it. We also have what's called, well, it's a learning management system. It's an online learning management system at Normandale. Almost all schools have it now, where the lectures are available online. They have textbooks. They have study guides that are online. They have quizzes that are online. I can do office hours either by telephone or over telepresence. At the remote locations, in industry, they typically have a senior level, maybe an engineer who's supporting, or a professor or a college lab assistant on the college campuses. So the students have a lot of support. It's considered a hybrid between online and real time.
Where did the word Angstrom come from? It sounds Swedish.
It is. I can't remember his first name, but Ångström, yes, Ångström. He was a very early materials scientist in the late 1800s, and that dimension is named after him.
How are you going to replace yourself? Who's going to teach this?
That's an important question. And since I've been in the business for over 40 years, that's an important question to me. One of the advantages of telepresence is that the instructors don't have to be here. The instructors can be anywhere they've got a telepresence facility. So we're working really hard on updating the curriculum so that we can turn it over to someone less experienced. And they don't necessarily have to be here, but we are working with industry to try and get more instructors. We do have one other instructor who does a lot of who does some of the vacuum technology. Actually, we have two other instructors. Both of them are working in industry, so they're just available in the evenings. But it's a problem. It's a concern. Okay.
Well, thanks, Del.
I just want to show appreciation for speaking today. It's a gift on behalf of the club, a Rotary fan.
Thank you.
Thanks for your presentation.
Thank you very much.